The product of two positive integers is 2 power 9 into 3 power 5 into 5 power 4 into 7 cube. This is prime factorization. This product of these two numbers has 9 2's in it and 5 3's in it, 4 5's in it and 3 7's in it. Brilliant. Fine. So you need to, what that means, if I'm putting two numbers, two blocks, and multiplying these two to get this, that means between these two numbers I'll have 9 2's. Between these two numbers I'll have 5 3's. Between these two numbers I'll have 4 5's. Between these two I'll have 3 7's. What does that mean? This number could have 6 2's. This could have 3 2's. This number could have 4 3's. This could have 1 3. This number could have 5 power 1. This could have 5 cube. Could have 7 power 1. This could have 7 square. This is one possibility. Right? These two numbers will multiply to give us this. Our number has 9 2's in it. 6 here, 3 here. It has 5 3's in it. 4 here, 1 here. It has 4 5's in it. 1 here, 3 here. It has 3 7's in it. 1 here, 2 here. I can potentially break this like this. There some may be divisible by. May be divisible by. I don't even understand what this means. May be divisible by. Let's look at this example. 63. 63 is 7 into 9. 7 into 3 square. Will it be divisible by 7 into 3 square? This number is a multiple of 63. 7 and 3 square is sitting here. This number is not a multiple of 63. This combination, this doesn't work. But some other combination, it may work. Right? And then we'll have to worry about each of these. Beautiful question. And I'm going to find out whether I take each of these and I try to create a combination that works. That's my objective. I'm going to try to break this into two parts such that the sum is a multiple of 63. Brilliant. 63 is 7 into 3 square. So I'm going to try to do this by saying, hey, this didn't work out, but tell you what, I'm going to create one number that's a multiple of 63, another number that's a multiple of 63 within this set. Or I'll have a 3 square into 7 here and a 3 square into 7 here, and then see if I can fill the rest in. What does that mean? 3 square into 7, 3 square into 7. There's a 3 square here, 3 square here. I have 5 3's with me. I put 2 here, I put 2 here. I'll have one more with me. Maybe I'll keep it here. 7 and 7. I have 2 7's I've accounted for. I have 7 cube. I have one more 7. I'll put that here. This number is a multiple of 63. This number is a multiple of 63. I don't care about how I put the remaining. Maybe I'll put all 2 power 9 here. I'll put all 5 power 4 here. This works brilliantly. I've broken this into two parts such that this is a multiple of 63. This is a multiple of 63. That means if I add one multiple of 63 and another multiple of 63, I will definitely get a multiple of 63. Their sum may be divisible by 63. Of course, it may be divisible by 63. That works, but I'm not too fine. I'm too comfortable. I look at the first thing, it may be working. Now I'm worried. What if all of these are working? Maybe I'm making some mistake. So what am I going to do? I'm going to say, hey, I'm going to find a mechanism whereby I can try to do this also. If I can do this, then I'm in trouble. Everything is possible. If I cannot do this, then I'm confident. Only this works. I've tried only one choice. Let me do the other choice also. Number is a multiple of 27. That means 27 is 3 cube. I'm going to take this number. I want this number to be a multiple of 27. This number to be a multiple of 27. So I put a 3 cube here and a 3 cube here. Oh, that's not possible. I have only 5 3's with me. I put 3 3's here. I don't have 3 3's to put here. Put a 3 cube and 3 cube. I need 6 3's. I have only 5. It is impossible to have two multiples of 27. Now I get another interesting idea. If I add two multiples of 27, I'll get a multiple of 27. If I add one number that's a multiple of 27 and another that's not a multiple of 27, I cannot get a multiple of 27. But I can have two numbers that are not multiples of 27 that add up to give me a multiple of 27. Think about this. 13 plus 14 is 27. This is not a multiple of 27, this is not a multiple of 27. But they can add up to give me a multiple of 27. Is that possible? I have 5 3's with me. If I put this to be not a multiple of 27, that will end up being a multiple of 27. If I put only 2 3's here, 3 3's will have to go there. One of the two numbers has to have 3 cube in it. But both numbers cannot have 3 cube in it. So any which way I break, one of these will be a multiple of 27, other one will not be a multiple of 27. I add these two, I cannot have a multiple of 27. It will never happen. So 27 is ruled out. 32, now I've got the hang of this. 32 is 2 power 5. That means this number needs to be a multiple of 32. This number needs to be a multiple of 32. That means I'll have to put a 2 power 5 here and a 2 power 5 here. Not possible. I have only 9 2's with me. I cannot put 5 2's here and 5 2's there. I don't have it. At the same time, one of these two numbers will definitely be a multiple of 32, because if I put 4 2's and 4 2's, I'm using only 8 2's. That's not right. I have to use up all 9. So definitely when I break this, one of the numbers will be a multiple of 32. The other one will not be a multiple of 32. I cannot add this and get 32. 32 is out as well. 196. 196 is 98 into 2. 98 is 49 into 2. 49 is 7 square into 2 square. So I want two numbers. One that has 7 square into 2 square. Another one also has 7 square into 2 square. Not possible. I have only 3 7's with me. I cannot put 2 7's here and 2 7's here. I have only 3 7's. So I cannot have two numbers that are both multiples of 196. Not possible. I cannot have a scenario where both are not multiples of 49. That's not possible either. Because if I put 7 here, there will have to be a 7 square. So I will have two numbers that are multiples of 49. So they will add up to be a multiple of 49. So there will be one number that's a multiple of 49, another one that's not a multiple of 49. I add these two. I will not be able to get a number that's a multiple of even 49. There's nothing possible that's a multiple of 196. Therefore, this one also does not work. Only one possible answer, 63. I can break this into two parts such that first one is a multiple of 63 and second one is a multiple of 63. I simply cannot break it into two parts such that first and second are multiples of 27, first and second are multiples of 32, first and seconds are multiples of 196. Not possible. Doesn't work. And beautiful question. Really, really, really tough.